So hi, in this video we are going to solve this integral I that is given by integration of ln secant square of x plus tan to the power 4 of x dx, limits going from 0 to pi over 2. Fine. So I can rewrite this as 0 to pi over 2 ln 1 plus tan square of x plus tan to the power 4 x dx. Okay, so let take tan x as t. So tan x is equal to t, which gives us secant square x dx is equal to dt, and again secant square is 1 plus tan square x dx is dt, and we took tan x as t, so we get 1 plus t square dx is equal to dt, which finally gives us dx as dt over 1 plus t squared. So our limits would also change, and that would be as x goes to 0. So tan x would go to 0, which implies t goes to 0. As x goes to pi over 2, tan x would go to infinity, so t tends to infinity. So our integration now becomes I is equal to integral of natural log 1 plus t square plus t to the power 4 dt over 1 plus t square. And since you can see we have 1 plus t square here and here as well, so for using the Feynman's technique, let's take I of alpha as integral of ln 1 plus t square of alpha plus t to the power 4 over 1 plus t square dt, and limits would be same, 0 to infinity and 0 to infinity. Fine. So what do we require? So we want the value of I of 1, right? So when alpha is 1, we get, so this is equivalent to this for alpha equal to 1. Okay, so let's do that. Okay, so what Feynman says is to differentiate under the integral sign. So of I of alpha is equal to d over d alpha, like this, and when you take this differential operator inside, it will become partial derivative. So what we get is this is equal to integral 0 to infinity natural log of 1 plus t square times alpha plus t to the power 4 over 1 plus t square dt, and this differential operator will become partial derivative. And so now let us just differentiate this. We get 1 over 1 plus t square times alpha plus t to the power 4 times 1 plus t square using the chain rule, and finally, since 1 over 1 plus t square is a constant when you differentiate with respect to alpha and not x, sorry. So you get dt like this. Fine. And clearly this cancels this out, so what we get is, also we forgot the integration sign. Okay, so finally what we get is this integral of 0 to infinity 1 over 1 plus t square times alpha plus t to the power 4 dt, and this is what? I prime of alpha. Okay, now let's do some substitution. So let t is equal to root of alpha over x. So dt will be root of alpha times minus 1 over x square dx. And now let's just make that substitution to get this as integral of 1 over 1 plus t is what? Root alpha by x, so root alpha by x squared times alpha plus root of alpha over x to the power 4, and dt is what? Root of alpha times minus 1 over x square dx. And we also need to talk about the limits. So limits, so as t tends to 0, x would have to go to infinity, and as t goes to infinity, x will go to 0. So this would be infinity to 0, and since we have this minus sign, we can just swap these limits. So what we get is this integral of 0 to infinity root of alpha over x squared by 1 plus alpha over x square times alpha plus alpha square over x to the power 4 dx. And now let's just multiply the numerator and denominator by x raised to 4. So we get this as 0 to infinity root alpha x square over x to the power 4 plus alpha by x square alpha times x square alpha plus alpha square dx, and which is what? This is equal to integral of 0 to infinity x square over root of alpha by x to the power 4 plus alpha x square plus alpha dx. So we did this step because the denominator here is same as the one that we have here. Since we can change the variable of integration, we have this is equal to 0 to infinity t square over root of alpha by t to the power 4 plus alpha t square plus alpha dt. Fine. This is also I prime of alpha. Let's call this as 2, and this is also I alpha, so let's call this as 1. Now let's just take the sum of these two integrals, and then we get 2 times I prime of alpha is equal to integral 0 to infinity t square over root of alpha plus 1 over t to the power 4 plus alpha t square plus alpha dt, which gives us I prime of alpha as 1 over 2 root of alpha integral 0 to infinity t square plus root alpha over t to the power 4 plus alpha t square plus alpha times dt. Yep. So now if you observe, we are quite familiar with this type of integrals. So now we divide this by t square and denominator as well. So what we get is this. This is also equal to 1 over 2 root of alpha integral 0 to infinity 1 plus root alpha over t square by t square plus alpha over t square plus alpha and dt. So what we do, let's just take this, push this aside. We add plus 2 root of alpha minus 2 root of alpha. So if you look, these three terms combine to make the following: 1 over 2 root of alpha integral of 0 to infinity 1 plus root alpha t square and t minus root alpha over t square plus alpha plus 2 root of alpha times dt. Now if you observe, if you take t minus root alpha over t as u, so what we get is 1 plus root alpha over t square dt is equal to du, and you know this formula as well. Also you must know this formula, that is 1 over x square plus a square dx is equal to tan inverse x by a whole over a plus c. Similarly, and this is exactly the same form, this is x, this is your a square, and this is your du. So we can just directly write this as this is equal to 1 over 2 root of alpha 1 over root of a plus 2 root of alpha tan inverse t minus root alpha over t over root of alpha plus 2 root of alpha, and with limits going from 0 to infinity. So we are just almost done. So we get this as 1 over 2 root of alpha 1 over root of alpha plus 2 root of alpha, and let's see, if we, so the denominator is actually a constant, and if you place infinity in the place of t, this goes to infinity and this term goes to 0, so the whole value will approach infinity. So tan inverse infinity will be pi over 2 minus, now the other way around, if we place the value of 0 in this one, this would go to 0, and if you place the value of 0 to this term will go to infinity and this term will go to minus infinity. So in the end what we get is tan inverse minus infinity is minus pi over 2, and finally we get 1 over 2 root of alpha 1 over root of alpha plus 2 root of alpha and times pi. So your final answer is pi over 2 root of alpha plus 2 root of alpha, which this is your I prime of alpha. Okay, again let's just revise. We wanted I of 1, we have I prime of alpha. So if we integrate I prime of alpha d alpha, we will get some I alpha plus some constant, and this constant can be a bit of trouble. So for any limits a to b, we need to have the value of at least one of this either I of A, or we need to have the value of I of B. So our original question requires the value of I, which is what we said is I of 1, and let's just subtract 0 for the moment, and we'll look at it why we did that. So now just look at I of 0. What is this? This is integral 0 to infinity ln x to the power 4 over 1 plus x square dx, which is what? 4 times integral of 0 to infinity ln x over 1 plus x square dx. Okay, so we need to find the value of this, and we can easily evaluate that. So let's say let t is equal to 1 over x, so or x is equal to 1 over t, so dx is equal to minus 1 over t squared times dt, and let's just substitute that. So we get this is equal to 4 times integral of 0 to we need to keep track of the limits as well. So as x goes to 0, t goes to infinity, and as x approaches infinity, t approaches 0. So the limits would be reversed, infinity and 0. So ln 1 over t dt over 1 plus 1 over t square times t square, and times minus 1 as well, this minus 1 which I forgot. So this is equal to 4 times integral of 0 to infinity minus ln t dt over 1 plus t square. So we flipped the limits here and here because of this minus 1, and we got this minus sign because ln 1 over t is minus of ln t. So what we got here is this is equal to minus 4 times integral of 0 to infinity ln x over 1 plus x square dx. We can always change the variable of integration, and again this is minus 4 times I of 0. So in the end what we got is I of 0 is equal to minus 4 times I of 0. So this implies 5 times I of 0 is 0, which gives us I of 0 is 0. And this is the most important thing that we had to observe to solve this question. Okay, so now I told you to do this, right? So okay, so we wanted the value of I, and which we said it was equal to I of 1, and let's subtract 0 from this, and let's say I of 1 minus I of 0. Since we showed that this is true, we can write like this, and we can say this as this is equal to integral of 0 to 1 I prime of alpha times d alpha. Basically, if you integrate this, you will get I of alpha evaluated at 0 and 1, which will give you this. So there is nothing wrong in this. So let's solve this. This is equal to 0 to 1 pi over 2 root of alpha times root of alpha plus 2 root of alpha d alpha. Let's just check if this is correct or not. 2 alpha plus, okay, I think this is correct, and we can just factor out pi over 2 integral of 0 to 1 over root alpha times under root alpha plus 2 root of alpha d alpha, and let's make a substitution. X is equal to root of alpha, dx is equal to 1 by 2 root of alpha d alpha. So we have this right here, this and these two terms. So we get dx. So this is equal to pi times integral of 0 to 1 over x, not x, root of x plus x square plus 2 of 2x and dx, right? So we can write this as pi times 0 to 1 by root x square plus 2x plus 1 minus 1, or let's just use a different color, plus 1 minus 1, and dx. This is equal to pi times 0 to integral of 0 to 1 under root x plus 1 square minus 1 dx, and this is a standard integration form, and the formula is integral of 1 over x square minus a square is equal to dx is equal to natural log of modulus of x plus under root x square minus a square plus c. So we get this as this is equal to pi natural log of modulus of x plus 1 plus under root x plus 1 squared minus 1 squared. And this is evaluated from 0 to 1. Okay, so what we get is this is equal to pi times ln 1 plus 1 plus root of 2 squared minus 1 minus natural log of 0 plus 1 plus root of 1 square minus 1 square. This is 0, so this whole is 1, so this whole natural log goes to 0. So this is equal to pi times natural log of 2 plus root 3. So here we are. So our problem, integral of 0 to pi over 2 natural log of secant square x plus tan to the power 4x dx is equal to pi times ln 2 plus root 3. And if you have noticed, we also got this as well, 0, this is also equal to 0 to infinity ln 1 plus x square plus x to the power 4 over 1 plus x square dx. So this is also a common Feynman integral problem. So this gets converted to this. So yeah, we have covered exactly 2 questions in this video. If you enjoyed this video, please give this video a thumbs up, share it with your friends and family, and if somehow and even minutely, if this provided some value to you, definitely please subscribe. Thanks for watching. Bye.